In this lesson, we learn about tracing the curve corresponding to reciprocal function of the given function, which is very interesting skill because in this skill we assume the role of a detective trying to trace route of a thief who came to break in and then left in the dark. Let's get started with the given function. The given function is a straight line. Given function is y is equal to 2x minus 5. So this clearly is a linear function and will represent a straight line. Let's draw the graph for this function y is equal to 2x minus 5. If we compare it with slope-intercept form, compare with y is equal to mx plus c. This means slope is m equal to 2 and y-intercept c is equal to minus 5. So the graph of this straight line intersects y-axis at 5 units below the origin. So 1, 2, 3, 4 and 5. That is a point right here. And because its slope is plus 2, it means 1 unit right, 2 unit up. So this is the slope. So now it's not hard to find the graph for this straight line because all the points of this line lie on one linear path. So let's draw the graph here. So this will be, this is the graph of the straight line. It's not exactly what I wanted it to be, but it clearly represents a straight line. And the equation of this straight line is y is equal to 2x minus 5. Now we want to graph the reciprocal function, which is, now the reciprocal function is of the given straight line or linear function. Linear function is, just reciprocate the right hand side. So this will be y is equal to 1 over 2x minus 5. This is the reciprocal function which we want to trace. And before we can trace this, we will try to collect the following pieces of information. The first information that we need about this function is asymptote. So let's get started. So number 1, we need asymptotes. Asymptote and asymptotes for y is equal to 1 over 2x minus 5. There is an easy method to find asymptotes by equating coefficient of highest power of y, highest power or exponent power of y to 0, we get asymptote parallel to y-axis. We get asymptote parallel to y-axis. So what is the coefficient of highest power of y? The highest power of y in this function is 1, like y power 1. So if we write this equation in this form here, 2x minus 5 times y equal to 1. What is the coefficient of y? The coefficient of highest power of y is 2x minus 5. So if we put that coefficient of y equal to 0, means we have 2x minus 5 equal to 0, means x is equal to, this means 2x equal to 5 and x equal to 5 by 2, means x equal to 2.5. So this is asymptote parallel to y-axis, or it's called vertical asymptote. Let's write it down. So this was for vertical asymptote. Vertical asymptote. And now we want to find out the horizontal asymptote. For horizontal asymptote, similarly, we are going to compare coefficient of highest power of x to 0. Now we compare coefficient of highest power or exponent, coefficient of highest power of x equal to 0. So for the equation, what was the equation there? The equation was 2x minus 5, 2x minus 5 times y equal to 1, which means if we want to find out just coefficient of x, this would be 2y times x minus 5y equal to 1. So the coefficient of x in this equation is 2y. Therefore, we are going to substitute 2y equal to 0. This means 2y equal to 0 is horizontal asymptote. Horizontal asymptote, or more specifically, y is equal to 0. Y is equal to 0 represents x-axis. So x-axis is asymptote here, and here this is asymptote. So this is easy way to find two asymptotes, vertical asymptotes and horizontal asymptotes. If we want to trace these asymptotes on this number, on this graph, that's going to help us a long way. So let's write this equation of asymptotes here. This is 2.5. So here is that asymptote. It means the graph of the given reciprocal function will just travel along with this vertical asymptote, but will never cross it. And obviously the other asymptote is just the x-axis itself. So we have a little bit information how the graph is going to travel along these two lines. So this line is x equal to 2.5 and this line is y is equal to 0. Once we have found asymptotes, next we are going to find out the invariant points. Invariant points. For invariant points, we are going to put y is equal to 1 one time, and another time we are going to put y is equal to minus 1 for the given equation of reciprocal function. Substituting y is equal to 1 for reciprocal function. So if we substitute y is equal to 1, this means 1 is equal to 1 over 2x minus 5. So from here, we will find out the value of x. This means 2x minus 5 is equal to 1, or in other words, 2x is equal to 1 plus 5 means 2x equal to 6 or x equal to 3. So the point 3, 1 is invariant point. It means that this point lies both on the given straight line as well as the reciprocal function. And let's also find the second invariant point. For second invariant point, substitute y is equal to minus 1. For this, if we substitute y is equal to minus 1 in the given equation for reciprocal function, this will be minus 1 equal to 1 over 2x minus 5. This means minus 1 times 2x minus 5 equal to 1, or this will give us 2x minus 5 equal to minus 1. So here 2x is equal to minus 1 plus 5, or 2x equal to 4 and x equal to 2. So let's write these symbols as well. So the other invariant point. Is 2 minus 1. Let's go back to the grid where we want to graph it. So we have 2, 1 and 2 minus 1 and 3, 1. So let's see. 2 minus 1. Where is 2 minus 1? 2 minus 1 is right here. This is the point where this is 2 minus 1. 2 minus 1. And 3, 1 is this point here. So this is 3, 1. These are two invariant points. Let's also find out what are intercepts. So let's find out intercepts. Intercepts. For y-intercept, let's put x equal to 0. This means in the equation y is equal to 1 over 2x. Instead of x, we are going to place 0. Minus 5. This means y is equal to minus 1 over 5. So the y-intercept for the reciprocal function. So the y-intercept for reciprocal function is 0 minus 1 by 5. It means on the grid, this graph of reciprocal function intersects y-axis almost at this point, which is 1/5 of the square below the origin on x-axis. Okay, Now we are pretty clear how this graph is going to go, because x-axis is asymptote, so obviously graph is gonna come from this side and cross y-axis. It has to cross y-axis at point -1/5 and 0, because that was its y-intercept. It also has to pass through this invariant point. So from here it will go to invariant point, and once it crosses invariant point, it has to go along this other asymptote, because with this asymptote this has to continue going and will not touch or cross. Similarly, the other side, this graph is similarly going along this line x equal to 2.5, and at some point has to cross this invariant point and then travel along the second asymptote. So this is exactly the graph of reciprocal function. This is graph of y equal to 1/2x minus 5. So now you know, if we find out these pieces of information about the graph of reciprocal function, if we find asymptotes, if we find invariant points, we find intercepts, it becomes a lot easier for us to find out how this graph of the given reciprocal function will be. So that's it for now. We'll see you in the next lesson.